In this topic, we're going to cover C data types and structures. This is a Python focused course. However, when interfacing with the Windows API from Python, we need to have an understanding of C. C is a lower level programming language when compared with Python. C is compiled while Python is interpreted. And C requires you to specify your data types. C also has fewer built-in standard functions and is comparatively more difficult than Python. And that's because Python abstracts away more complex components, for example, memory management. And in C, we have the concepts of pointers and structures. When you create a variable, that variable itself has a memory address. So the variable has a value, but it also has a memory address because the variable has to be somewhere in memory to exist. And pointers are just variables that store addresses and not values. While structures, or structs, are collections of grouped variables. And a structure groups those variables under a single defined type. So you can think of structures as similar to Python objects. So with some high-level theory out of the way, let's jump back over to our virtual machine. The ctypes module, which is included in the standard library, is a foreign function library for Python. Ctypes provide C-compatible data types, which allows us to directly call functions in DLLs or shared libraries directly from Python. So let's get started by working with some ctypes data types by importing from ctypes and saving this ctypes structs.py. And as we know, when using or declaring variables in Python, we don't need to specify their type. This can make Python scripting quicker and easier, but this can also cause us problems. For example, if we try to concatenate a string and a number, Python can't guess what it is that we are trying to do. And with other languages, such as C, when working with these variables, we need to first specify the type of that variable before declaring or using it. So let's start by creating variables which are of a C-type Boolean. So we can create B0 is a C bool, and B1 is a C bool. We can print these out. Execute this. And here we can see our output. 0 is false, whilst 1 is true. And we can also print out the type of B0 and the type of B1. And we can also directly print out the value. And here we can see B0 is false and it's of type bool, while B1 is true and it's also of type bool. And we don't need to only work with booleans. We can also create an unsigned integer, for example. And we can again print this out. And here we can see the maximum value for an unsigned 32-bit integer. We can also create strings. Which are actually null terminated char pointers. And when changing the values of pointer type instances, we are actually changing the memory location the variable is pointing to, not the actual contents of that memory block. And so we can see this. We print out C0. And now we can set C0 to another value. We can print this out again, as well as the value. And we can see our different locations here. And so when working with pointers, we need to be careful if we pass them to functions expecting pointers to mutable or changeable memory. Because, as we have just seen, that's not how ctypes works in Python. We need to instead use the create string buffer function, for example. So here we've created a 5-byte buffer, which has been initialized with null bytes. And we can verify that by looking at the raw memory contents, as well as the null terminated string. And now we can change the value at this address. We can print this out. So we can see the address remains the same. However, the value has changed. And in case the function you are working with is expecting a Unicode buffer, for example, then you would need to instead use the similar create Unicode buffer function. And we have only demonstrated a few of the standard data types here. In the official ctypes documentation, you can see an extensive list of the C data types available to you within Python via ctypes. And we can take a look at these. And so these are the different fundamental data types which are available to you within Python. And pointer instances can also be created by calling the pointer function on a ctypes type. So for example, we might have an integer here. And now we can also create a pointer to that integer. And these pointer instances have a contents attribute which returns the object to which the pointer points. So we can print out I, also print out the pointer to I. We can print out the contents. And these pointers are useful because sometimes a C function will expect a pointer to a specific data type as an input parameter, which is known as passing by reference. Passing by reference can be used if the function wants to write to that location, or if the data being passed is too large to be passed by its value. And to help with interfacing with these functions, we can use the ctypes by ref or pointer functions to pass parameters by reference. So we already know what's stored at P0, which we defined up here. Let's change this to test. So here we can see at P0 we have the value of test. And we can also print out the address of P0 in memory. And we can also create a reference to P0. It's out as well. And now that we have this reference, we can also use cast. And cast returns a new instance of type char pointer, which points to PT, which can be used to look at the actual data stored at that address. So for example, we could say print cast PT. And this is quite a complicated way to access the data, but the power of pointers means that we can do whatever we want with this data based on the reference that we already have. So for example, we could instead use cast as an integer and view the contents. And we can make this a bit easier for us to verify by changing the contents back to the value of A and running this again. And so here we see the value of 97, which is the integer representation of A. And now that we have an understanding of some data types, let's move on to structures. And structures are derived from the structure base class defined within the CTypes module. Each subclass must define a fields attribute, and this attribute is a list of tuples containing the field's name and the field's type. So for example, we can recreate our person class from the object-oriented programming lessons as a C-type structure. So we can create our class person and define our fields. We need a name, which is a character pointer. And we need an age, which is an integer. And now that we have our structure, we can use it. So we can create Bob again. And we can print out Bob's name and Bob's age, which we can see here. We can also reuse the structure, so we can create Alice. And we can print out Alice's name and her age. And we already know how to work with lists in Python, but when using a list or an array with CTypes, we need to set up and manage space a little differently. We first need to multiply a data type with the number of elements we want to have in the array. So for example, we might want to have a person array for 3 people. Which we can see here. And now we can create a person array with our person array type. And we can add people to this person array. So let's create Bob again. Alice again. And Mallory. And we can print out each of these people. And here we can see the 3 person objects in our person array. And if we try to add another person to our array, we can see that we have an invalid index because there's not enough space for our 4th person unless we change the type. And CTypes is a really useful and powerful library which enables us to use and interface with lower level C data types directly from within Python. And CTypes can be daunting if you haven't worked with a lower level language before, but the documentation is verbose, and CTypes will enable you to easily work and interface with native code from within Python. But that's it for now, and in the next lesson, we are going to cover interfacing with the Windows API.